All right, so looking at these more complex derivatives, this is a trig one. You're going to have to use chain rule. I would rewrite it first. So I'm just going to rewrite it. And remember that this 3 is not included in the squared. It's this thing squared. So I would rewrite it like this, 4x. Think of it like that. So this is going to be a chain rule. So 2 times 3. So when I take the derivative here, you're going to have 6. And then you recopy it, decrease the exponent by 1, so now it's to the first. Then it's time the derivative of the inside. Well, the derivative of the inside, the derivative of sine is cos of that thing. Now you need to multiply that by the derivative of that, so that's just a 4. So you can clean that up if you wanted to multiply this 4 by that 6, that's fine. You may not multiply this 4 by either of these 4 x's though. So if it was simplified to be 24 sine 4x cos 4x as your final answer there. Okay. When you're taking the derivative of e raised to a power, all you're going to do is rewrite it and then you multiply it by the power. I'm going to write this one, and I guess I could fit it right here. Let's see. So the derivative there, you recopy it. Then you multiply it by the derivative there, so that'll be multiplied by 8x. And then that'll just be a plus 7. So again, they might rewrite that one as 8x e to the 4x squared plus 7 separately. And then that would be how I would leave it. For C here, the derivative of ln of anything, all you do is it's 1 over the parentheses times the derivative of the parentheses. Another way to think of it is the derivative of the stuff over the stuff. So I think of the derivative, I like to think of it as 1 over the original multiplied by the derivative of that original. So the derivative there is a 10x. Now you can rewrite it like this. And then you can reduce it if you want to risk it. But remember, if you simplify incorrectly, you will lose points. So let's see, that's 2 in the numerator and x in the denominator there. Okay, in number 5, we are writing the equation of the tangent line. So whenever you see equation of the tangent line, you should be thinking take a derivative, you plug in the x value given, and then you're going to use point slope formula. So for this derivative, think of this as your first, and this is your second. So when you're doing product rule, okay, so I'm going to take a derivative. So it's first times the derivative of the second. The derivative there is just 1, plus the second times the derivative of the first. So we've got that as our derivative. You can choose to clean that up if you want. But really you're going to end up evaluating it at 1, so that's not too bad. So to show that I'm evaluating the derivative at 1, that's that notation. And so when you plug in 1, you get like 1 minus 4 minus 7 times 1, so you've got this. Plus if I plug in a 1 here, that's 2 times if I plug in 1 there, that's 2 minus 4 is a negative 2. So, let's see, negative 3 minus 7 is negative 10, and that's a negative 4, so I got a negative 14 there. And then you have to take that 14, and you're plugging into y minus y1 equals m parentheses x minus x1. So they gave you the x right here. You do need to go and get your y1 by plugging this into the original. So if you plug 1 into the original, I'll just do that off to the side here. So y of 1, well, you're going to get 1 minus 4 minus 7 times 2. So that gives you negative 20. Okay, so now when I go up here, I do y minus a negative turns to a plus. My slope was negative 14. Parentheses x minus x1. That would be your safe stop. If you insist on simplifying, you can simplify it to that if you want to keep going. Okay. All right, number 6 says find the slope, not the equation of the tangent line. So make sure you're answering the question that they ask you. Here, we get to stop like right after you find the slope. Okay, so all I need to do is find the slope. To find the slope of this, that's asking for the derivative. Here you have to use implicit differentiation because you're taking the derivative of multiple variables at the same time. So start by taking the derivative with respect to x. And what I would do then is, so here when you take the derivative, you're going to get 8x. And that'll be plus 3y squared. Again, you took the derivative of something that's not an x, so you have to tack on a dy dx. And then equals the derivative of negative 4 is 0. Now your goal here is to solve for dy dx. So you're going to have 3y squared dy dx equals negative 8x. And you are going to divide by 3y squared. Okay, so you've got dy dx equals negative 8x over 3y squared. And it did give us an x value there and a y value. So all you're going to do is evaluate it. So to show that, you can just say dy dx evaluated at 1, negative 2. So let's see, if I plug in 1 for x and plug in a negative 2 for the y value, that gives me negative 8 over, let's see, that's 4 times 3 is 12. And so yeah, my final answer there would be something like negative 2/3 is my final answer. Okay, and there's the end of that page. Okay, number 7, I would definitely make sure I know how to do this one. There's one just like it on the test. So here, they're basically giving you a point, okay? This is basically telling you have a point at 3, 4, and they are evaluating the derivative at 3. So they're telling you what that equals. So again, when you see write the equation of the tangent line, you should be thinking, take a derivative, use point-slope formula. Well, they kind of did that easy part for you. So if you think about your point-slope formula, y minus y1 equals m, parentheses x minus x1, they gave me a point. So I'm going to grab my y value from there, so that'll be a minus 4, equals. The m value, let me just pause there for a second, and I'm going to kind of skip it, and then say my x value is this, so minus 3. So to get m, what did we do when we found the equation of a tangent line? We took a derivative, then we plugged in the x value they gave us. Well, they're telling us that when you plugged in that x value of 3, from this 3, that you got a negative 7. So this is the negative 7 right there. That would be your safe stop, and all you'd have to do is clean it up if it was multiple choice to get this. Okay, the table below gives values of f of x and g of x and their derivatives. So basically, we are saying we're going to have to use the product rule here. Okay. First, though, I don't even need to do that. It just says evaluate h at negative 2. Well, if h is f of x times g of x, that's going to be the equivalent of f of negative 2 multiplied by g at negative 2. Well, f of negative 2 is 3, and g of negative 2 is 5. So this is just 3 times 5. So my answer there is just a plain old 15. All right, now it's saying to take the derivative. So here, you have to use the product rule. So the product rule says first times the derivative of the second plus the second times the derivative of the first. And now basically you're plugging in negative 2's for all those x's. Well, if you plug in a negative 2 there, f of negative 2, well, that's going to be a 3. So you've got 3 times g prime of negative 2. So g prime of negative 2 is negative 3. Plus g of x. Let's see, g of there is going to be a 5. And f prime of negative 2 is a negative 4. And from there, you're just kind of cleaning up. Let's see, that's negative 9 minus 20. So my final answer there is going to be a negative 29. This one is a little bit of a pain because you have to use the product rule twice. It's saying take the derivative of this thing here. Well, the derivative of this thing, you're going to have to use product rule here, and then product rule again here. Okay? So watch this. It's going to be first times the derivative of the second. Well, the derivative of g prime is g double prime plus the second times the derivative of the first. So that takes care of the derivative of this left-hand side here. Now I need to do the product rule again for this. So you have first times the derivative of the second plus the second times the derivative of the first. Okay, barely fit it on there. And again, now you're just evaluating, you're plugging in -2 for all of these things. So when you plug this in, that'll be 3 times -1 plus -3 times -4. And then I've got g of -2 is going to be 5 times 2. I've got -4 and a -3. So if you clean that all up, I don't have the room, I'm just going to say that that's going to be 31. Okay, when you clean it all up. Okay, find the second derivative. So the second derivative just means the derivative of the derivative. So I need to find y prime. Okay, the derivative of sine is cos. The derivative of cos is a negative sign, but it's a negative. So that's going to make it 3 sine theta plus 2. The derivative of sine is cos theta. So we've got that for our first derivative. And now we are going to take the derivative of that. Okay, so you're going to take the derivative of that. And so, let's see, the derivative of sine is cos. So it's just going to be 3 cos theta. And the derivative of cos is negative sine, so it'll be -2 sine theta. Notice that there was no chain rule or anything on this because there's no parentheses around this, so you don't have any chain rule there. Let me just scooch this up. Okay. At which x values does the graph of f of x have a horizontal tangent line? Horizontal tangent line means that you're going to take a derivative, set it equal to 0. So when I take the derivative of this, okay, so that's going to be 1/3 times 3 is 1, so it'll just be x squared minus 36. And now I need to take the derivative and I set it equal to 0. So that's like saying, where does this equal 0? Two ways you can go from there. You can factor this into x plus 6, x minus 6, or you could just add 36, take the square root. Either way, you're going to get x is equal to plus or minus 6. Okay? And then I'm done because it just said at which x values. Well, when x is 6 or -6, you're good there. All right, last one on this page. Find the value of p that makes the function differentiable. Make sure that you know the difference between differentiability and continuity. So to figure out where something is differentiable, oh, and this was a mistake. Make sure you're fixing this. See how this is a 2 here? This should be a 2 over here. Okay, sorry about that. I don't know where that 4 came from, but yeah, this should be a 2. It's got to match here. So we want it differentiable at 2. Okay, so very similar to when we're finding continuity, you can figure out where a function is differentiable. So we need to take the derivative of each part of this. Okay, so I'm going to say f prime equals, and then I just kind of keep it in that same notation, keeps things straight. So I take the derivative here, keeping in mind that p is just you're going to treat it just like a constant, right? So you would just say it's 3px squared. Okay, and then the derivative of this piece over here is going to be 4x cubed plus 2x. And again, these restrictions are the same over here, right? This is for when x is less than 2, and this is for when x is greater than or equal to 2. Okay, and for this to be differentiable, I need to set those two things to be equal to each other. Okay, so here I have x is 2, so I can plug in, again, this 2 I had to change it. That 2 goes in for an x. So I've got 3p, and I plug in x is 2 squared, equals 4 parentheses, that'll be 2 cubed, plus 2 times 2.